In this video, we are going to look at a modified problem from the AIME, which is to simplify the square root of 104 times root 6 plus 468 times root 10 plus 144 times root 15 plus 2006. Pause the video, give a try, and resume when you're ready. Because this is a problem in a maths context, so we should be quite certain that the number inside the set should be a perfect square of some more elegant expression. Now notice that we have square root 6, square root 10, and square root 15, and 6 is actually equal to root 2 times root 3. This is root 2 times root 5, and this is root 3 times root 5. So it's a legit guess that this expression, the number in yellow, is the square of some number times root 2, some number times root 3, plus some number times root 5. Well, in other words, it should be a linear combination of root 2, root 3, and root 5. Because when we look at the square of this expression, we should have 2a squared, 3b squared, 5c squared, by squaring each individual term, and then we pick any two of them, multiply and double it, so we have 2ab root 6, maybe I wrote it, and then in the next row, plus 2ab root 6, plus 2ac root 10, plus 2bc root 15. So now we can compare like terms, and we'll have 2a squared plus 3b squared plus 5c squared equals 2006. That's not very helpful, but the common 3 will be much better, which is that 2ab is actually exactly 104, 2ac is 468, while 2bc equals 144. So simplifying, we'll have AB equals 52, AC equals 234, while BC equals 72. Now this system is actually solvable because I can multiply all three equations. I will get a squared, b squared, c squared. The terms are spread evenly among a, b, c. Now the product is a bit more complicated, but we do not need to multiply to obtain the exact number because I can try to rewrite into product of primes. 52 is 2 squared times 13, while 234 is 13 times 18, while 72 is 2 squared times 18. Of course, 18 can be further simplified, but we do not need to do that here. And simplifying, we'll have 2 to the 4 times 13 squared times 18 squared. So that means ABC should be either 4 times 13 times 18. Now this is the positive case, or it can be minus 4 times 13 times 18. Now when we get the value of A, B, C, I can find values of A, B, and C respectively because, say, for example, A is just ABC over BC, and that's 4 times 13 times 18, okay, I said plus or minus, over 72. Now notice that 4 times 18 is 72, so by simplifying, we'll have A to be either 13 or minus 13. Now, if A is minus 13, well, which means that we've taken the negative case, the one in yellow, then by doing the similar things on B and C, we'll have A, B, and C to be all negative, all negative. However, if A, B, and C are all negative, then by moving up, we'll see that I'm actually saying that the square root of this number is a negative number, but that's wrong. So, which means that we must have A, B, C to be all positive. Now we can move back to the product of A, B, and C. So this is wrong. We cannot have this. I do not need this, and I do not need this. So A has to be 13. Similarly, B can be this. So that means it's divided by 2, 3, 4, and that will give B to be 4. And so finally, for C is equal to ABC over AB over 72. So 52 instead. And so that's 18. So that means A is 13, B is 4, and C is 18. Now what remains is to put this back into our first equation to check that whether 2a squared plus 3b squared plus 5c squared is really 2006. Now by checking, we'll have that's the first one is 338 plus 48 plus 5 times 324, and that's 1620. And you add them up and you get exactly 2006. So that means these are really the solutions. And so we've guessed it right, and our answer will be 13 square root of 2 plus 4 square root of 3 plus 18 square root of 5. And this is our final answer.